Hello future engineers, viewers, subscribers, and students. Here is another video in structural analysis, particularly on the topic indeterminate and sway frame. This is the second part. This problem was given as one of the problems in the final summative exam in structural theory or structural analysis from the university where I teach that course or subject. So for the frame shown, determine the support reactions at A. A is constant. So this is the given figure. If you evaluate the degree of indeterminacy, there are 3 at A and 2 at D. So therefore, this is indeterminate to the second degree. There are only 2 redundant forces. If we choose method of least torque as the method to be employed in the analysis of this frame, which I do for this video to because if I'm going to present another solution, this will lengthen the video. So just see for the other solution to this in the future. So there are, as I said, 2 additional unknowns. So this is indeterminate to the second degree. So I select AH and AV as the redundant forces. You can choose DH and DV if you want as the alternate solution, but in this case I just select AH and AV as the redundant forces, and I express MA in terms of these 2 redundant forces. So for the sectioning, this is section 1, that's X. Slope 7.5 vertical, 4 horizontal, so that's 15 vertical, 8 horizontal, so that's why this is 15x over 17, 8x over 17. At section 2, that's x, and at section 3. So expressing W in terms of x by similar triangles, W as to x equals 15 as to 12, so W is 5/4 of x. So the moment later in this section is 1/2 of x, 5/4 of x, x over 3, so that's 5 over 24 x cubed minus 5 over 24 x cubed. So expressing MA in terms of AH and AV, so we sum up moments about the equals 0, clockwise positive, so we have MA plus AV times 9 minus AH times 4.5 equals 15 times 5 plus 15 times 5 times 2.5 plus 1/2 of 12 times 15 times 12 over 3 or 4. Simplifying MA is 4.5 AH minus 9 AV plus 622.5. So we have to set up the first equation, partial of U with respect to the first redundant, which is AH equals 0. So that is EI partial of U with respect to AH equals 0 equals integral 0 to 8.5 of AH times 15x over 17 plus AV times 8x over 17 plus MA, which is equal to this. You just copy. Derivative with respect to AH is 15x over 17 plus 4.5 divided by 1.5 because I is 1.5. Then plus in this section, integral of AH times 7.5 plus AV times quantity 4 plus x minus 15x minus 15x x over 2 or 7.5 x squared. Derivative with respect to AH 7.5 plus 4.5, and that's 12 dx. Then in the last section, plus integral of AH times quantity 0 to 12, by the way, limits AH times 7.5 minus x plus AV times 9, then plus MA, which is we just copy, then minus 15 times 5 minus 15 times 5 times 2.5, then minus 1/2 of x, 5/4 of x, x over 3, and that's negative 5 over 24 x cubed. Derivative with respect to AH 7.5 minus x, plus 4.5 or 12 minus x. So evaluating the coefficients of AH for the first integral, so that's 412.25, for the second 720, and for the third integral of 12 minus x quantity square 0 to 12 divided by 2. This is divided by 2 because EI is 2. We will get these values, then plus for AV, these are the coefficients, and the constants after transposing to the right would be this. For the first, 622.5, quantity 15x over 17 plus 4.5 over 1.5. That's the value, negative 29101.875. Second, you just do your part, viewers, integrate and transpose. Then for the third. So simplifying, we can now set up the first equation, 1 for 20.25 EH minus 5557 over 12. AV equals negative 72,115.875. Let's call that equation 1. Then for the second part, EI partial of U with respect to A vertical equals 0 equals, we copy this moment equation. The derivative with respect to AV would now be 8x over 17 minus 9. So that is, we copy. Then partial derivative of this moment equation with respect to A vertical is quantity 8x over 17 minus 9 over 1.5. Second, we copy and we replace this derivative by 4 plus x minus 9, that's x minus 5, dx, limit 0 to 5. So x minus 5 dx. Then for the third, we copy again. Then we replace 622.5 minus 15 times 5 minus 15 times 5 times 2.5. But the derivative is 9 minus 9, so 0. So everything would be 0 in the third integral. Because the derivative of this moment equation with respect to AV is 0. So setting up the second equation, coefficients of AH, expected that it should be equal to this, negative 5557 over 12. Remember the technique. So AH times negative 3757 over 12 and negative 150. 0 in the third, as I said. Then plus AV, 0 at the third term. Then equals, for the constants after transposition, these are the values except for the third, which is again 0. So simplifying this equation gives negative 5557 over 12 EH plus 2942 over 9 AV equals 31,770.625. So solving equations 1 and 2 simultaneously, we obtain AH is negative 35.472 kilonewtons. So since we assume leftward, the value of AH is, the direction of AH is rightward, and it is 35.472 kilonewtons. AV is 46.94 kilonewtons, and MA, after substituting the values of AH and AV into this equation, we obtain MA equals 40.416 kilonewton meter positive, so the assumed direction is correct. and that is clockwise. So that's it for this video.